Hi, welcome. So, in the last video, we looked at numbers, and in the preview video before that one, we looked at strings. So, we are now going to go on to look at lists. This is also a very commonly used data type in Python. So, let's just go straight to the computer and look at lists. So, here I've just created this title list, and then I've created two empty lists, and then an example of a list called list one. So you can just pause the video and type this same thing. So there are times when you need to initialize lists by declaring an empty list, and then maybe you add elements to the list gradually. So it's good to know how to create an empty list, and these are the two ways of creating it. Either you just use this empty, this both of these like brackets like this, or you use this list function with nothing inside. Then this is an example of a list that you would be this is an example of a list which is made up of different elements: 1, 2, 3, 4, 5 elements, because in a list the elements are separated by the comma like this, and then it starts with these brackets here like this. So this is a list. So, and if you can see, there is a list inside this list. So list can contain all types of elements, numbers, strings, even lists inside other lists. So that is one interesting thing you should instantly note about lists. It's like you can dump any kind of thing inside a list. So let's run this. So this is there's no error, everything is initialized here. And if you want to print, for example, the empty list one, empty list one, we can run it, shift enter, it gives us an empty list like this. Empty list 2, shift enter again, it gives us same, both of them are empty lists. And if you want to print list 1 to see what it's going to give you, it gives you that list. So it starts with this and ends with this, and then this is one of the elements of the list. Then now you can also do a type to check what is the type of data here, because data structure type here. So if I press shift enter, then now I have it clearly as a list. Now that we know that we have a list, let us check the usual things we want to check is, can we access the first element? And remember, as we said in the video with strings, Python is a zero index element. So to access this first element, we'll be saying list 0 to get this one, list 1 to get this one, list 2, list 3, list 4. So even though there are 1, 2, 3, 4, 5 elements, you'll be starting with 0. So we saw that, we discussed that in an earlier video, that Python is a zero index programming language. So let us go on now to see if you can access an element in a list like the 0 element, and if so, we'll conclude that lists are ordered. So let's do that. List 1, then we are going to say 0, and then we run it and see. So it gives us the 1 that we expected. So list 2, the second element is 2, even the third element is 2. Good. So it looks good. So the way we're doing slicing in strings, like we introduced it here, we can do the same thing here. So remember, we looked at it when we were doing strings, and we said it's good to know how to slice like this to take the first element, which is 0 element, and then the element number 1. So it will just take this 2. So because this is 0, 1, 2, it will not touch this one. So if, for example, I want to include this one, I have to take 0, 1, 2, 3 and write 4 here, so that 4 is just there to tell it to stop before 4. So we looked at that in the video with strings. So just play with them, try out things. Put 3 here and see how it's going to turn out. Put 2 here and see how it's going to turn out, and then you would know. So the other thing we did in the last video, in the video with strings, was that we said to get the last element, you just need to use a -1, and then if you want to get a couple of elements towards the end, maybe from here right up till the end. So we looked at that in an earlier video. You can always go back and check. It just shows that the list, you can be able to slice out the list. So list is ordered. That is confirmed that a list is ordered. Now the next checking we usually want to do is to check, can we replace an element? Can we substitute an element for the strings? We're not able to. We try to substitute the first element in a string and we got an error saying strings, you can't substitute an element. So strings are not mutable. Once you've created a string, you can't change the elements. Sure, you can use methods to do that, but then the string by default is not mutable. And for the list, let's see if the list is mutable. When you create a list like this, can you just come in and change this element maybe to Python or to R or to 3 or to 8 or to 12 or whatever? So that's what we want to do now. So let's just copy the list again, and then we just bring it here again just to run it again. Then we say, now let us try list 1. I'm going to just copy this and say, okay, the first element, remember the first element here, 0 is 1. So can we change this maybe to 8, for example? So let's run it and see. So we didn't get any error. Now let us print this list again. Remember in as we talked about in Jupyter notebooks, you can either just run it like this or you wrap it around with the print statement. But why, if you're using VS Code without the IPython notebooks, you must use the print. We discussed that in an earlier video. So now you see the list has changed from 122A to 822A. So we confirm that lists are mutable, unlike strings. So let us check now a few methods with lists. We looked at some methods with strings. Let's see a few methods with lists. So let me just copy this again, paste here, and then now we can look at a couple of just a few methods. So if one of the methods that you would want to see is the append, and we can say list dot append. So it's something you will be using a lot. So let's just say append maybe Python, and you see what is going to happen. So list 1, this is a reserved word. So we need to be sure that we call this variable list 1, which is what we created. So if we come here and then we print list 1 to see now how it's going to look like, we see that we have been able to add Python at the end of it. So let's run this. You see, so this is our list, this is our append, and we've been able to append at the end Python. So we could append even other lists. You could append even a long list here to that list, and it's still going to work out. So remember to access the elements. If you are confused, there are so many to access the methods. If you are confused, there are so many methods. So remember, you can always give the name of your list or the reserved word list, or just this list 1, anyone. We saw it in an earlier video. Dot tab, and then you see append was one of them. Clear, copy, count, index, insert, pop, remove, reverse, sort. So if you noticed, if you're observant in the video before this one, or let me just show you here, I'll use the reserved word string. So str.tab, string has its own methods, and this is one important thing about Python object-oriented programming. For the string, there is no append. There is upper and lower, which we saw. This is very important to know, and the method is after the object. So string dot maybe upper, list dot append. So it's like that. So list, now when you go to list, it has its own things that it can do. So object-oriented programming, the object of list is recognized, and then it has things that it can do and things it can't do. So hope that is understood. And again, you can always go to help, for example, help, and then you say, I want to understand maybe what list.pop does. We saw it there as one of them. So it's going to tell you built-in instance removes and return item and index. So it removes item at index, default is last. So you can specify the index, or if you just type it like that, it's going to remove the last item. Let's say like this last item is going to pop it off, kick it out. So let's try that now and see. So the interesting thing about pop is that it saves what it just popped out. So you could tell it to pop out the last item. Maybe you don't know what the last item is, and then you call it and say, what was the last item you popped out? So it tells you, actually, this was the last item I popped out. So let's just see. So if you go to popped list, so if you say popped list, for example, equals to list one dot pop, and then we can print the list. Remember, your method should always have this thing open and close. You can print the list. And the good thing about pop is that you can also print the popped item. It stores it. So maybe you don't even know the last item. You just say kick out whatever last item is there, and then you tell me the last item. So let me go to my popped list. Okay, so I change this to item. So pop list. So here we are. So our list one, it kicked out this last item. So this is our list one. This is our list. So it kicked out this last item from here, and it stayed just with this 122A here. So that is the advantage also of using pop, because pop would be able to remember what it just popped, like we saw here. So there are lots of interesting methods. Again, you just go to help, like we saw here, try to research on it, try to play with them, and there are lots of examples in the documentation which would help you to be able to do that. So you can even, let's say you want to insert an element in a specific position in the list. So we have that list again. This is our list. Example, this is our list. And then you want to insert a specific element. So you can say list dot insert. Then you might say where do you want to insert it. You need to specify the index. Do you want to insert it at the position 1, at the position 2, at the position 3? Let's just put 2, and then we say we want to insert z, just something like that. And then we say let's print now the new list. So let's print our list 1. So let me fix this. So list dot insert, it should be a dot insert, and then let's see. So this is a reserved word. Remember, reserved word. So you need to get the 1 here to say it's what you've defined. So now you see we have 1, 2, and this z 2A. So we've been able to say insert it at this specific position, or we can say insert it at the 3rd, insert it at the 4th, whatever. So that is something you can do with lists. So now there are so many interesting things that you can learn from lists. I'm introducing you to them. So, but let's look at something which is how you copy lists. How lists, that when you do a copy of a list, how it behaves. So let's just do that, and then we will be able to move on to the other data structures as we go through this our introduction. So copy a list. So, and then now I'm going to show you. So let's say this is list 1. So we can, if we say, for example, list 2 is equal to list 1. Now, let's see what is going to happen. So if we pop list 2 dot pop, we take out an element from list, we say list 2 dot pop, right? Then we print out list 1 and list 2, list 1, and then we print out list, we print list 2, list 2. So when we run this, we see that list 1 had all these elements, including this list in a list. List 2 is equal to list 1. So we created a new list and said this should be equal to this one. We went to list 2 and did a pop like we saw earlier here. So which means we kicked out this one, and list 2 was supposed to remain like this. But when we print list 1, that same element 2 is kicked out as well in list 1 as it was kicked out in list 2. So it seems as if these two are moving together. So let us check something here and check if list 1 and list 2 are identical. So we can check here and say print list 1 is list 2 and see if it will be true or false. So let's see. So it's true. So actually list it this when you create a copy like this, it the second one, they have the same identity. So it's just anything you do on any one of them is going to affect the other one. So be very careful when you create a copy of a list, because you might be deleting things here thinking the first original one is safe. It's not safe. Whatever you delete to the copy is going to affect the original one. So how do we stop this from happening? That's when we have to use the method now of dot copy. So we'll say copy a list with dot copy. So let me just copy all of this here, change just that, and then you're going to see the difference. So what I'm going to change here would be list 2 equals to list 1 dot copy. So these methods are very interesting and it's good to review them. So if I run this, now you see what we wanted to see. List 1 remains as it was with the 4, 5, the list in the list, and then list 2, the element that was popped in list 2, it only affects list 2. So if we check whether they are identical, Control Z, Control C. If we check whether they are identical, it says false. They are not identical because of this dot copy. So this one occupies its own space in the memory. This one occupies its own separate space in the memory. So whatever you do to this one doesn't affect this one at all, and whatever you do to this one doesn't affect this one at all. So I hope you've been able to learn how to use lists. You've been able to see if they are ordered, if they are mutable, and of course we've seen duplicates there, so which means lists accept duplicates. So let us continue to explore the other data structures as we work our way towards doing big data analysis work in Python. See you next video. Wish you good data luck.